Good morning, Year 10. In this video, we are going to look at the 5 questions from Week 2, Term 3 for Friday. The first question asks us to solve 3x plus 4 all over 5, which is greater than 2. So we're going to solve this the way we would a normal equation. The difference is that we have the inequality here. So first of all, I'm going to times everything by 5. Okay, now when I do that, I'm going to just have on the left-hand side 3x plus 4, which is greater than 2 times 5 is 10. Then I want to get x by itself, but that 4 is in the way, so I'm going to do the opposite, which is take away 4. 3x is greater than 6. And then I want to get x by itself, so I'm going to divide both sides by 3, which gives me x is greater than 2. And that's it. We don't need to flip the sign for this one because we're not timesing or dividing by a negative. Okay, question 2. If Tony earns $50 and that's for M in 5 hours T, find K where M is equal to K times T. So to find K, we're just going to substitute in those values. This is a direct proportion. So effectively, Tony earns $50 for K lots of time, which in this case is 5 hours. Now we want to know what K is, which is basically how much he earns per hour. So I'm going to divide both sides by 5, and then we'll get 10. So K is 10. He earns $10 an hour. Next, we've got an inverse proportion. If Jane is travelling at 60 kilometres an hour, S, which is speed, and she travels for 30 minutes, T, which is in time, find K. Now this one, it's not as straightforward as you'd think when you first look at it, because you'll see here, this is kilometres per hour, and this is in minutes, so we need to change this to hours. So there's 60 minutes in an hour, so he's travelling for, so I'll just say T is equal to, half an hour. Okay, so I'm just going to change it to half an hour. Okay, you could also have written that as 0.5 as well. So now that we have that, I'm going to put it into the formula. So 60 kilometres an hour is equal to K over 0.5. And so I could have done the half, but with the fraction, but it doesn't really matter. And I want to get K by itself. So I'm going to times both sides by 0.5. So that means we've got 60 half. K is going to then equal 30. Okay. Great. We can move on to question 4 now. Given y is equal to 3x plus 1 and y is equal to minus 2x plus 6, find the value of y for each equation when x is equal to 1. Okay, so for this we've got 2 equations. So I'm going to draw a line in the middle. I'm going to do it for both. Okay, so the first one, I'm just going to say when x is equal to 1, we have y is equal to 3 lots of 1 plus 1, which is 3 plus 1, so y is equal to 4. Okay, now we'll do the same for the other one. So when x is equal to 1, y is equal to minus 2 lots of 1 plus 6, which is minus 2 plus 6, so y is equal to 4. So they're the same. What that means is that that's actually a simultaneous solution when x is 1 and y is 4. We'll look at that more in a topic later down the track, but I just like to keep it in our minds so when we see it, we know what we're doing. Now the last question, complete the table of values for y is equal to x squared plus 1. So for this, in your calculator, this is where I'd recommend you would write, we don't have the y, we can't type that into the calculator, but instead of having x like that, we're going to write it like this. So whatever value of x we are using, we pop it in there. So the first time we'll do it for -3, and then we'll see what our answer is. So I'll do brackets -3 squared plus 1 gives me 10. So I'm going to write 10 in here. And then we do it again, but with -2, which gives us 5. So I'd write 5 here. And then so on. So I'll do it for -1, which gives me 2. I do it for 0, which gives me 1. Do it for 1, which gives me 2. Do it for 2, which gives me 5. And I do it for 3, which gives me 10. Okay, we're going to look at this type of graph. So this is still a graph. That's why we do a table of values, so we can graph it. You'll notice that for this particular one, it goes down, and then here it starts to go back up again. And it's symmetrical in that way around here. So we'll look at that more, but I just want you to think about it now. All right, we're going to go on to distance time graphs next. So if you could please move on to that video.